Okay, quick synopsis, what we said about constant growth rate models. First of all, constant growth rate is not rate of change. If the growth rate is R, and we can think R is 0.05 for 5% interest, let's say, because interest compounded yearly would be one example. Then R would be 0.05, our growth rate is 0.05, and then you have growth factor. It's a factor because it's what you multiply by. Now you know when we did interest, we added the 5% to 1. Well, we originally said we have 1 plus 0.05, and we raise that to the number of years. Okay, well, we add the 1 and the 0.05, we get this thing that I call the growth factor, and that's just a word that we can apply to the thing that we already understand. Okay, and we have our initial quantity, our t equals 0 quantity, and we have our model. So that would be our principal model for interest compounded once a year. If it's compounded more than that, well, you know what to do with that. Okay. Now this is an exponential of the form y equals ab to the t, where b is the thing that's raised to the t. That's your growth factor. And if you know what the growth rate is, you add it to 1 and you get your growth factor, so you'll know what b is. If you know what your initial amount is, well, there it is, and you've got your model. And this applies to populations. It applies to a wide variety of things that grow in such a way that the amount of change in any period is some multiple of how many you have. Okay, said a little more about that in the longer video. Radioactive decay, you have a decrease. So if you have a certain amount of radioactive substance, we'll call that R, okay? And you know that it decreases by 5% every period, and the period might be seconds, it might be minutes, it might be hours, days, months, years, millions of years, billions of years. It depends on what the substance is. We got substances that decay in any of those time frames. But if the rate is negative 0.05 for every period, whatever the period is, days, years, centuries, whatever, then your growth rate is negative 0.05. If the activity or the amount of stuff decreases by 5% every period, then your rate is negative 0.05. That's your growth rate. Your growth factor then is 1 plus the negative 0.05 or 0.95. So your model would be, well, it'd be a y equals ab to the t model, with b being your growth factor, 0.95, and a being your t equals 0 amount. And in terms of the amount of radioactive substance, if we let R be the amount, R equals initial amount, R naught, times 0.95 to the t. Now once we have a model, it should be obvious that we can solve questions about the model. We can construct a graph, we can do all the stuff that we know how to do from the other parts of the course.